So we're here with the Infratab. So who are you?
I'm good. My name is Gary Saxer. I am the Chief Evangelist for Infratab. Infratab makes products that monitor, track, and trace perishable items. This is an example of one of our tags. This is an 11 centimeter tag. This is a tag which has an RFID sensor over here. It has a temperature sensor here. We have a battery right here because that's what runs the temperature sensor, and you'll notice that there's some distance between these two. This is an 11 centimeter tag. We make these in various different sizes between about 4 centimeters and hundreds of centimeters. We've made them many meters long, separating the RFID from the temperature sensor.
And then the battery, how long does it last?
Battery lasts at least a year. For most people, most of our customers reuse the tag about 10 times before it runs out. Now we also have some lights right here. If you watch, I'm going to push the button right there. You should be able to see the light flash red twice. I'm going to do it again. Watch again right there. I'm going to push the button and the light flashes red twice. This is a way of being able to find out information about the tag without using RFID. We can flash green twice, green once, red once, or in this case, red twice. These tags are made to be flexible. For instance, here's one that we use inside reusable product containers called RPCs. It's folded and flexible like this so that it fits inside the handle of the tag. Inside, close to the product, is where the temperature sensor is. On the outside, where it's dry, is where the temperature is where the RFID is. Now, in addition to that, what we do is we take every single product and we customize it. What I like to be able to say is this is the tag that we use for grapes, and this is the tag that we use for strawberries, and this is the tag we use for ice cream, and this is the tag for pharmaceuticals, and this, you see, they're all the same tag because we can customize the program. This is the profile of a tag, and the profile consists of various different features. The major feature is the temperature profile. What we're looking right now is the temperature profile of blueberries. Blueberries have a Q10 of about 2.5. The Q10 is the rate of change of degradation for a biological substance. This is 2.5. If instead I was going to be testing ice cream, I'm going to guess that ice cream is about 12.5. I press the apply button right here, and we now have ice cream capability here. So the idea is we can customize this information for a specific product, and by doing that, I have the information for that particular product. Once we gather the data for that product, we can get information retrieved from it. This is a log of some data. You can see that the red is hot and the blue is cold. We keep track of the hottest point and the coldest point for every 1% freshness. We keep 100 data points. Notice, for instance, how far apart the data points are here. That's because it's all being maintained properly. Notice over here where it got really hot, there's lots of data points. They're all crammed together because this is a smart data logger. It gathers more data when bad stuff is happening. The net result is that instead of keeping hundreds or thousands of data points, we keep 100 data points, but they based on the knowledge of what the product is. Because once it gets down to zero, we don't keep any more data because the product is dead. We already know it's gone. By using 100 data points, we can then tell you how fresh the product is. Somewhere between 100, perfectly fresh, and 0, all the way gone. The product does this using either the lights or using RFID to be able to tell you not just if it's fresh, but how fresh is it. This is called, a product's called Infratab Fresh Time. I'm Gary Saxer.
So this is really important for all food in the world that gets transported. It needs to be
perishable item. Any item that's perishable, anything that degrades for these temperature sensors based on temperature, any perishable item. That's why pharmaceuticals, blood, ammunition, paint, adhesives, cosmetics, anything that degrades uses a Q10 based on the Arrhenius equation. That's been done a long time ago. Based on you'll have to look up in Wikipedia Q10 or Arrhenius, and you can see how that works. They all work with that. That's the science behind this. We customize a tag for a specific product. Food is one of them. Remember, there are 4 different kinds of spinach. The Q10 is different for each of the 4 different kinds of spinach. So you need to know the exact model of spinach in order to do that. There are, of course, scientists who know this information. We also have a quick and easy way of being able to show you how to do that. If you're interested in knowing what the Q10 of a product is, let's take an example. Give me something you want an example of here.
Swiss chocolate.
Swiss chocolate.
But that's good chocolate.
Yeah, well, okay, we're gonna call it Swiss chocolate here. What we say is that Swiss chocolate, when it's kept close to freezing, we're using Fahrenheit here, close to freezing, let's say if it's kept at 33 degrees Fahrenheit, that it's going to then last, at 33 degrees Fahrenheit, it's going to last, I'm going to say 60 weeks. It can last more than a year close to freezing, okay? But when it's at room temperature, 72 degrees Fahrenheit, well, it can only last a week, let's say. Well, actually, what would be a better number? Let's say a month.
Yeah.
Let's say a month, okay? Because then it starts to go bad. So what we have just done is we have just calculated the Q10 based on those values here, Q10 being 3.4999, essentially 3.5. We've just been able to get, now that was a rough guess. If your scientists knew more specific numbers, they would know exactly what that is. And now we have the temperature curve. You put these tags, we generally put these tags on cases at a time or pallets at a time. The tag runs at about $15 for a tag, a retail tag for like this. Each tag, remember, being used at least 10 times or about a year. That's normally about $1.50 a run. As a result of that, you can use RFID to program the tags. You can use RFID to get information out of the tags in doing that.
Is it possible to change the battery and keep it, or you have to buy a new one every year?
We change the battery. We charge a recycle fee for every tag so that you send it back to us, and then we replace the tag for the recycle fee, basically, for being able to do that.
So is this full mass production?
These are mass produced. That's right.
And many people are using them.
We make thousands of these tags. We have people using these tags in various different places. These are intended mostly for the cold chain. You're not going to see one of these in your refrigerator. You're going to see one of these in your refrigerated truck, or you're going to see it in the warehouse or the pre-cooler, or maybe out on the farm when they're first harvesting the flowers or the grapes or the pineapples or whatever it is you're doing there. And so that's the way that these particular products are used.
Nice. And here, the printed electronics IDTechEx, there's a lot of people working in this area.
This is a star example of printed electronics. This is an absolutely great example of printed electronics. I want you to remember that I said that there's an RFID chip here, and down over here is where the sensor chip is. You'll notice that there are some traces in between. If we need to make this tag 20 centimeters long, we simply print longer to 20 centimeters. If we need to make it 100 centimeters long, we just keep on printing. And the idea for this is that we don't have to keep making a different mask for every type of one. We simply specify how long to print in between the two. Now, if you have a product that has an RFID sensor and a RFID chip and a sensor chip of any kind on the other side and some distance between them, we own the patent on being able to separate the two of those.